Hi guys, thanks for tuning in to another episode of Nuggets News. I'm super excited today to have Edgar, who's head of Hashgraph in the Asia Pacific region. And there's so much to discuss today. We often hear about blockchain, and we've discussed other forms of distributed ledger technology, tangles, and distributed hash tables. But I'm so excited to dive into Hashgraph. So thanks for joining us today, Edgar.
Well, thanks a lot for having me here, Alex.
So to start off with, do you want to talk a little about the history of Hashgraph and then how it sort of developed into the public Hedera Hashgraph?
Sure. Yeah, it all started in 2012. So Dr. Lehman Baird, the inventor of Hashgraph, in 2012 was working on trying to find or figure out or invent a consensus algorithm that was asynchronous Byzantine fault tolerant. So this the highest level of security possible in distributed consensus. This standard of security has been in existence for almost 3 decades now. But up until Hashgraph, no one had come up with a solution that was both ABFT and scalable. So Lehman started working on this problem in 2012, and he went down rabbit hole after rabbit hole, and it was at times convinced himself that it was possible. But in 2015 had a breakthrough, and the breakthrough is what we now call the Hashgraph consensus algorithm.
So I want to dive into that consensus mechanism a bit more. So asynchronous Byzantine fault tolerance is a bit of a mouthful, but do we have a sort of easy way for someone at home, rather than comparing it to a blockchain where we put transactions in blocks and they get added to the previous one? Do we have a sort of easy way for someone at home to follow how this works?
Yeah, so for something to be, first of all, Byzantine fault tolerance, there has to be a couple of different criteria. So one of them is actually finality. So by that, I mean, you need to be 100% certain that a transaction has been confirmed. And if you look at proof of work blockchain, for example, you're never actually 100% certain that transaction has been confirmed. You only become increasingly sure that a transaction has been confirmed as more blocks are added to the chain.
And that's
Right?
really important for people at home because of the longest chain rule. It could take, a month, and then we discover that there's a longest chain out there somewhere. So that's what Edgar means by we're never 100% sure. We don't have finality.
Sure, that's right. So for something to be BFT, you need to have finality, which Hashgraph achieves, and achieves within seconds. You get 100% finality. The other piece of it too, the term asynchronous, it essentially means that when you look at different types of BFT, you make certain assumptions around that claim. So, for example, certain protocols might assume that the attackers cannot attack will not attack the network within a certain period of time, or the network's resilient from attacks within a certain period of time. And with Hashgraph, we don't make those kinds of assumptions. So the only assumptions that we make are that no more than 1/3 of the nodes are malicious, which is true for all distributed ledger technology. And essentially, the attacker can control the internet, but as long as some messages get through the network some of the time, the network can still come to consensus.
Yeah, I appreciate you trying to break that down. It's always
Yeah,
difficult to explain it in easy terms, but we'll dive into that 1/3 consensus a little bit later on, a little bit more. So, do you want to
sure.
talk about other aspects of the protocol, the gossip about gossip, and also the voting, which people are really excited about?
Sure. So it goes back to a consensus algorithm that's been around for a few decades now. It's categorized as a voting-based algorithm. Essentially, how it works is that a node will send out a question, usually related to the order of the transactions that have occurred. So, for example, I would send out a question to the network: did the green transaction come before the red transaction? And then every member of the network will then cast a vote. And they won't send a vote. They'll send a vote not just to the node that asked the question, but they'll send a vote out to all the nodes in the network. And typically, when the nodes receive a vote, they will send out a receipt, and again, to all the other members of the network. So the voting-based algorithm achieves the highest level of security possible, so this ABFT standard. However, the bandwidth requirements in terms of sending the votes and receiving the votes are quite punitive, and therefore makes it unscalable. So Lehman figured out a way that for a voting-based algorithm to work, or for votes to be calculated without votes having to be sent over the network. And quite, at a very high level, it uses the gossip protocol, which is quite common in computer science. It's the fastest and most resilient way of sending a message out to the network. So essentially, all nodes, if I've received a network, or I create if I receive a transaction or I create a transaction, I will gossip it out to other members of the network. That means I will pick other members of the network randomly, and I will send the transaction to that random member. And then in the subsequent round, both myself and the other member will gossip the transaction out to other members of the network randomly. So the message gets sent out exponentially across the entire network. What Lehman figured out is that by adding 2 hashes to each of these transactions, the hash of the last transaction that the sender created and the hash of the last transaction that the receiver created, we are able to create this diagram, what we call the hash graph, that gives you the entire history of who has talked to who and when. Yeah. And every member of the network receives this identical image of the hash graph. And so when trying to calculate consensus, instead of me asking you, hey, did the red transaction come before the green transaction? Because I have the image of the hash graph, I can calculate what you would have voted if you were to have cast a vote on that order of the transactions. So, and I can calculate the response for every other member of the network. And so without votes having to be sent over a network, I can calculate what everyone else would have voted, which also means that very quickly, we all come to the same answer, meaning that we all come to consensus very quickly.
And that timestamping was one of the final pieces of the puzzle to develop Hashgraph, wasn't it? That what allows us to put that in some sort of 2-dimensional representation, because everything is timestamped.
Yeah, so everything is timestamped, and that's true of many consensus algorithms. But the unique thing about Hashgraph is that if I send you a timestamp, you don't actually have to trust that my answer. So the way Hashgraph looks at fair ordering of transactions is you take the median timestamp in which every member of the network had received that transaction, right? So and that allows us to calculate very fairly without the network having to trust the initial sender. That allows the network to calculate the timestamp in which the entire network received that transaction, and that's fair. So no member of the network can manipulate the order of the transactions that enter into the ledger.
So Hashgraph started off as a private technology, and I just want to talk about how many nodes were running it privately, how many, I think it's a couple of dozen now in the first sort of public test nets, and in future, can anyone run a node? And I believe this takes very low CPU capacity, so they're talking about being able to even do this on your mobile phone, for example, and does this work at scale, and is the plan to get it to thousands of public nodes?
Sure. So let me take that question a bit at a time. So Hashgraph was invented in 2015, and Lehman spent most of 2017 fine-tuning the technology. He published a technical white paper in 2016 and had it, and wrote the math proofs behind it. And in 2017 was when Mance and Lehman went out to, our co-founders, went out to commercialize Hashgraph. So we started in the private DLT space where, we licensed the technology to enterprises that wanted to build permission ledgers. And it was only in March of 2018 that we announced Hedera, and Hedera is the public ledger built on top of the Hashgraph consensus algorithm.
Yeah.
So in the rollout of Hedera, we'll start with our council members, and we can certainly touch on that a little bit later. But our council members are some of the largest enterprises in the world. So these are big, trusted global brand names, and they are running the initial nodes on the network. So there are up to 39 council members. So they will run. So the network will start out with up to 39 nodes,
yeah,
and beyond. And then at some point, when Lehman feels from a security standpoint he's comfortable enough with it, we will start sharding the network, and we'll introduce other nodes onto the network. So the second phase of nodes will still be trusted organizations, but very quickly beyond that will be the third phase, where we will open it up to anyone to run a node on the network.
And for those at home, sharding is something that Ethereum are aiming to do. Zilliqa have tried to implement. And I guess an easy way to describe this at home is if we have 100 nodes, once we get to 200, rather than having more working on the one piece of information, we have two lots of 100 nodes, and we start to break the network up into little pieces. So it's interesting that that's the plan for Hashgraph as well. But you said you wanted to dive into governance a bit later. So that was one of the questions I had about the famous witnesses and that governance and how that will change as we sort of have shards.
Sure. Yeah. I mean, well, the famous witnesses is a more technical aspect of Hashgraph. But I'm happy to touch on the governance piece.
Yep.
So if you look at many of the other public ledgers out there, the networks are essentially governed by, well, there are two main categories, I would say, in the public ledgers today. They're either governed by a foundation, where essentially a group of 5 to 10 people may be making all the governance decisions for the network, which is very centralized. Or you have the another model would be where the token holders vote and make decisions on the network, and that has flaws as well, because you end up having not a lot of the token holders caring about governance and participating in voting. Or you end up having centralization issues where some of the larger token holders collude with each other, and they end up creating centralization issues there.
It's certainly something that's been hotly debated at the moment, on-chain versus off-chain governance, and the best way to do it, that's for sure.
Sure. So our governance model is we're putting together this council of up to 39 of the largest enterprises around the world. So geo-distributed across the globe and across many different industry verticals, and representing many of the use cases that we expect to have built on Hedera. So, and essentially these enterprises, they own Hedera. We announced the first group of council members about a month ago. They are Deutsche Telekom, Swisscom. So these two are two of the largest telcos in Europe. DLA Piper, one of the largest law firms in the world. Nomura, one of the largest financial institutions in Japan. And Magazine Luiza, which is one of the largest retailers in South America, focusing on Brazil. And yeah, and we have signed on more council members. We will announce the next phase of council members within the next couple of months, and we'll continue to build up this council up until we reach 39.
So I'm trying to build the picture in my head of the scale of decentralized versus centralized, and a lot of libertarians are all for Bitcoin, proof of work, fully decentralized systems. And then we have the Neos and the EOSs of the world, where we have a small amount of nodes, particularly at the start, to coordinate everything. But I think this is very similar to IOTA, that has the sort of coordinated nodes, and then we're trying to get to a point where we can release it to the wild for the system to sort of run. So are you comfortable in saying that it is more centralized on that scale, but that's not really, Hashgraph isn't setting out to achieve a fully decentralized system? They're quite happy with what they've produced being different.
No, well, actually, that's not true. We we expect to we'll have the most decentralized architecture when we scale it out to thousands, tens of thousands, or maybe more nodes in the network.
Okay.
And from a governance standpoint, we also expect to have the most decentralized governance in the marketplace, right? 39 enterprises globally distributed, and so certainly better than 5 to 10 developers making all the decisions, or having a small group of let's say block producers that determine consensus, right? So I think one thing to keep in mind is, or maybe two things. One is decentralization is always a path, right? It's not. It's not something that happens on day one.
Yeah.
Bitcoin, for example, is started out. It was Satoshi Nakamoto, maybe Hal Finney as the initial miners in the network, right? But over time has scaled out to many different miners out there. Although you can also make an argument that the Bitcoin is very centralized and that it's now most of the mining or the hash power is controlled by a very small group of players in the marketplace. Yeah. But in Hashgraph, I think it's important to note that there's no node has more voting power over other nodes in the network compared to like a DPoS setup, for example. And certainly having 39 distributed council members participating in governance is more decentralized than the other models out there. And not only is it decentralized, it has these governing members contribute expertise in a lot of different areas and applications and use cases. So that's quite powerful as well.
That's fantastic. I've certainly learned something there, that it's starting off with a smaller number, but the plan is to become one of the most, if not the most, decentralized. So I want to build on that thought about the nodes, and if we can have any device having an equal say on the network, and we're relying on no more than 1/3 of the nodes being bad actors, can you maybe talk about the limitations and the risks for being attacked, or the double spend problem, and how the network sort of handles those issues?
Sure. So essentially, as long as So first of all, Hedera, the public ledger, follows a proof of stake model. So if you start with if you have a permission network, typically you have one node contributes one vote when calculating consensus in a permission network. Now, when you move to a public network, you can no longer have one node, one vote, because a bad actor could stand up, 1,000 nodes or more on the network and disrupt consensus. Yeah. So you need to have another form of essentially a scarcity or a scarce resource on the network, in which case is the tokens on our network, the H bars. So it becomes one token, one vote when calculating consensus. And so someone would essentially have to acquire more than 1/3 of the tokens in the network to be able to disrupt consensus in the public ledger. And we have implemented a variety of different mechanisms to ensure that it becomes practically impossible for any one malicious party to acquire more than 1/3 of the tokens out there. So it starts with a slow release of the tokens. So when we make the network openly accessible to the public this summer, at launch, we expect only a few % of the tokens to be in circulation. At the end of year one, probably in the 10 to 12% range. And over time, we will slowly release tokens out into the network over a long period of time. And that also allows time for more applications and use cases to be built on the network, so the network produces more and more utility over time. And at the point where the council decides to release more than 1/3 of the tokens out into the network, the idea is that the value of the token is sufficient that it becomes practically impossible, or a malicious party will have essentially zero incentive to go acquire, or it becomes cost prohibitive to acquire more than 1/3 of the tokens. And so it makes it practically impossible to disrupt the network.
Yeah. Can you talk about the fundraising a little bit more, how much you guys raised and that valuation, and I guess the other things that will bring that further utility to the token in future?
Sure. So yeah, in 2018, we did our fundraise from March till August. We raised $124 million via the form of a SAFT, Simple Agreement for Future Tokens. And this was sold only to accredited investors. And this is, so investors had to meet the minimum of the SEC requirement for accreditation. But the local rules for accreditation also apply. So for Australia, for example, I believe the minimum was 2 million Aussie dollars, which is closer to $1.5 million US dollars. And so when we raised money in Australia, that was the benchmark that we looked at. And we also did not raise money from certain countries, including China, Japan, and Russia, and a few other countries. We did this in compliance with the local regulations as well. So I think, as you look at Hedera Hashgraph, everything that we've done we've taken compliance and regulation into serious consideration every step of the way.
Fantastic. And what was the total valuation with all the tokens with that amount raised?
Sure. So the last valuation where we raised about 100 million of the 124 was done at a valuation of, if you look at total supply, it was done at a valuation of $6 billion. But if you look at it from a circulating supply, by year one measures, it will be somewhere between 300 to 600 million, depending on that circulation at that point in time.
Fantastic. So certainly one of the top 100 at the very least coins with that total supply would make it one of the top 10 coins by valuation. So other things that you guys are planning on implementing in the future. So I guess for people at home, it's important to understand that we have sort of internet as the base layer, that Hashgraph is that consensus protocol, and then we build on top of that. So smart contracts is something you guys are planning on doing, and you already mentioned sharding, but anything else you can share with us about the future?
Yeah, sure. So the network, like I said, will be openly accessible to the public this summer. For the last half a year or so, it's been closed access. So we opened up our network to developers that wanted to access our test nets. We also ran a community testing program in January. So there were 5,000 accounts created within a period of 2 weeks. During our community testing program, where users in our community can earn HBARs for helping us test the network. And it will be openly accessible this summer. And at that point, the network will launch with 3 initial services. So cryptocurrency, smart contracts, and a file service. So the way the network will function is that as applications are built on Hedera, and any of these APIs are called. So there'll be a cryptocurrency API, smart contract API, file service API. Anytime any of the applications triggers one of these APIs, there's a micropayment made from the application down to Hedera, and that micropayment is used to compensate the nodes on the network.
Fantastic.
So yeah, and we already have about 300 companies building on our test nets, and we expect about at least a dozen of these applications to be live and functioning when the network is openly accessible to the public.
So do you know what sort of yield, and can you dive into a little bit more for someone that wants to stake at home? And is this going to be freely tradable on lots of exchanges? Is that a priority for you guys, or something you just want to happen naturally from the smaller exchanges up?
Yeah, well, the only thing I can say about that is that we are speaking to the exchanges, and and going through the process with these exchanges. But we expect that, yes, at some point this year, application developers, our community members will be able to acquire HBARs through these exchanges.
Yeah, and about that proof of stake and the reward yield.
Right. So we don't have a sense of what the yield will look like at the moment. Ultimately, a lot depends on transaction throughput over the network. So that those numbers will only become more visible as the network is openly accessible and applications are running on the network.
Yeah.
But yes, we expect that token holders will be able to stake their tokens with nodes on the network.
Fantastic. And how's wallet development going? Are you guys trying to prioritize hardware support and all those fun things that we're waiting on all the large cap chains to sort of release?
Yeah, so wallets are already available in with iOS and Android, so you can go to download them. And then as far as hardware wallets, again, we're speaking to the largest providers and working on integration with them as well.
Fantastic. I've learned so much today. Edgar, any final thoughts for people at home about Hashgraph you feel we've missed? But it's been fantastic.
Well, no, I mean, just look out for our community testing program or the next phase of our community testing program that will happen probably at some point next month. And visit hedera.com to find out more information, and feel free to sign up for our email list.
I'll put all the links in the description below, guys. But thanks so much for joining us today, Edgar.
Great, thanks a lot, Alex.
Thanks, guys.